I numbered from 0 to 58, so technically there's 59 numbers along the circle. What we want to do is we want to show the 3 times table along this circle. First, we want to keep in mind the multiples of 3 of the numbers that are around this circle. So 3 times 0 is 0. I actually typed out the multiples just to sort of keep track of where I am and not mess anything up. 1 times 3 is 3. 2 times 3 is 6. All the way till we get around 58 times 3, which is 174. So now we just kind of want to take a piece of string and connect the numbers from around the circle to its multiple of 3. So for the first one, 0 times 3 is 0, so we wouldn't move a string anywhere. And then 1 times 3 is 3. So we take the string and wrap it around 1 and connect it to the number 3. So then we moved on to the second one. 2 times 3 is 6. So wrap one side around 2 and the other side around 6, and so forth. But when we get to point 20, 20 times 3 equals 60. But we have from 0 to 58, which is 59 numbers around the circle. So point 20 connects to what? To figure this out, we need to do something called modular arithmetic. One of the most basic is our clock, which has numbers from 1 to 12. So there are 12 numbers. And this is actually called clock arithmetic. So the mod for a clock is actually mod 12. Now modular arithmetic can actually be used in a lot of things, like figuring out the days of the week, checking check numbers, checking universal product codes, and even figuring out different mod clocks. Let's look at an easy example. If it's 11 o'clock and you add 4 hours, it will be 3 o'clock. Notice how 11 plus 4 isn't 15 o'clock because there's only 12 numbers on the clock. So when we get to 12, we start back at 1. Another way we can look at this is the process of long division. With modular arithmetic, we really focus on the remainder. If we look back at our example, if we take 11 plus 4 equals 15, but we want to know what time that is on a clock, We would first note that we are in modulo 12 because there are 12 numbers around the clock. However, our number 12 is equivalent to 0 because when we get to 12, we start back at 1. So for this problem, our divisor is 12. The dividend is the number 15. And 12 goes into 15 once with a remainder of 3. Let's say it's 11 o'clock and you want to find out what time it will be 16 hours from then. If you're like me, you would have to start at 11 and count 16 hours all the way around the clock. Or you can use modular arithmetic and some long division. First, you want to add the 16 hours plus 11 o'clock to get you 27. So the divisor is 12 because that's our mod. Our dividend is 27. And the remainder is 3. Again, modular arithmetic only really focuses on the remainder. So it would be 3 o'clock, 16 hours from 11 o'clock. Now I'm just going to show a couple of ways you could figure out the answer. First, 11 plus 16 is 27. 27 divided by 12, which is our mod. Take away a 12, we're left with 15. Take away another, you're left with 3. That is our remainder, which is what we're trying to figure out. So 12 is equivalent to 0 in mod 12. Now, 12 plus 12 is 24. We're trying to get to 27. So 24 plus what is 27? 24 plus 3 is 27. Again, 12 is equivalent to 0 in mod 12, so 24 breaks down to 12 plus 12, and then plus 3 equals 27. Cross off those 12s, and you get 27 equivalent to 3 in mod 12. 16 hours after 11 o'clock equals 3 o'clock. Now, back to our original problem. What do you connect 20 to when there is no 60? So for this circle, I used from 0 to 58. So that means we are in mod 59 because there are 59 numbers around the circle. So another way you can look at this is 20 times 3 equals 60. So 60 equals what? What we want to do is try to add the mod number to something to equal 60. So in this case, 59 plus 1 equals 60. So you would connect 0.20 to 0.1. So again, I just kind of put the numbers in a spreadsheet to not lose track. So 20 times 3 equals 60. And this column, I'm trying to find the remainder. So I'm going to equal it to be modulo operator, which is the dividend, which in this case is 60, divided by the divisor, which is our mod that we're using, which is 59, to get a remainder of 1. So on this side of the spreadsheet, I just kind of laid it out different. 59, which is our mod, plus our remainder equals 60. So what is 28 times 3? It's actually equal to 84. Well, what is 84 in mod 59? Well, we know that 59 goes in at least once, and if you take 59 from 84, you're left with 25. And a 59 is like adding a 0 in mod 59, and 25 again is the remainder. So 84 would be 25 in mod 59. So 40 times 3 is equal to 120. But what is 120 in mod 59? Well, we know that 59 goes in at least once, and it goes in twice to equal 118, and plus 2 gives you 120. 59 is equivalent to 0 in mod 59, so 0 plus 0 plus 2 equals 2. $59 times 3 equals 177. What is 177 in mod 59? Well, 177 minus 59 would give you 118. So 177 equals 59 plus, if you take out another 59, you get 59. So that's 2 59s plus the third 59. So 59 are again equivalent to 0 in mod 59. So 0 plus 0 plus 0, which equals 0 in mod 59. The sort of shape that we created is actually called a nephroid. Nephroid comes from the Greek word nephros, meaning kidney. And if you put the two kidneys next to each other, you can sort of visualize the shape that we created.